Welcome back. Let's do some more fundamental theorem of calculus using derivatives, taking derivatives of integrals, and let's see if we can do these. All right. In my other tutorial, in the first examples, I went through and explained how we can do it. I'm going to go through these a little bit quicker. If you want to try these and then look for the answers and listen to my explanation, go right ahead. That's what I would probably suggest in doing. But try these out, see if you can get them, and then check to see the answers or follow the video at the end. So without further ado, what we're going to do is we're going to find the derivative of this. Now, before we do that, I'm going to just write this out. The integral from 2 to x of this right here is going to give the antiderivative. Now, I don't know what the antiderivative is, so I'm just going to write a. So a stands for antiderivative. All right, antiderivative. So a is the antiderivative of, all right, the square root of 2 plus cosine of b. All right, so that's the antiderivative. So I'm going to find the antiderivative. I don't know what that is, so I'm just going to say it's a of t. But I'm going to take the upper limit minus the lower limit, okay? And we have this. So I'm now going to take the derivative of this. So what we have when we do that is going to be a prime of x minus a prime of 2. And I'll simplify this to be, well, the derivative of the antiderivative equals the function inside composed of that. So we're going to have is the square root of 2 plus cosine of t. Oops, not t. That should be x. All right, cosine of x. Cosine of x. And we have that. The antiderivative of a prime of 2, well, the antiderivative of plug in 2 is going to be 0. So our answer is just going to be 2 plus cosine of x. That's our answer. Cool. Next one. Once again, what is the antiderivative? We're going to put this as a antiderivative of that function right there. So we should have antiderivative composed of a of x minus a of 2. All right. When we do this one, to find this, we're going to have a prime of x squared. Oh, chain rule. All right. Since the antiderivative is composed of x squared, we're going to have to multiply by 2x to do the inside. Minus, what is the, we're going to have a prime of 2, which we know is going to equal 0. But let's figure this out. Derivative of the antiderivative equals the function inside. So we should have the square root of 5 plus quantity. Remember to plug that in there. X squared. That should be cubed. All right, times 2x minus 0, because the derivative of a number is 0. So we just have it 2x square root of 5 plus x to the 6th. And that would be our derivative of that antiderivative, of that integral. One more. See if you can do this one. Doing this one, we have, if we just did the inside, so we're going to have a, all right, antiderivative of the inside sine of x minus the lower limit, we have x squared plus x, like that. We're going to find the derivative. So we're going to have a prime of sine of x. Make sure we use chain rule. All right, which is going to be cosine of x, derivative of sine is cosine, minus now a prime of x squared plus x. Chain rule. When we take the derivative of this, we have to multiply by 2x plus 1. Make sure you put parentheses around that. So the derivative of the antiderivative equals the function inside. So it should be the cube root of, all right, plug that in there, sine of x plus sine of 4x times cosine of x. That's going to be on the outside. All right, minus, I'm going to run out of room here. All right, the cube root of, plugging that in there. So we have x squared plus x plus x squared plus x to the 4th power, all multiplied by the quantity 2x plus 1. And there we have it, my friends. That is our derivative of that integral. Big, bad, and ugly. All right. Well, once again, using the fundamental theorem of calculus, part 1 and 2, to help us understand how we take the derivative of integrals. Hopefully this makes sense. You got these 3 because this probably right here is probably the hardest one you're going to see in doing that. But remember, the derivative of the integral right, is the derivative of the antiderivative, which gives you the value or the function inside. Just make sure you integrate from the upper limit minus the lower limit when you're doing that. All right, good luck and God bless in the rest of your problems.